Welcome everyone. In this video, we're going to talk about hyperbolic functions. So these are the two definitions I'm going to show you, and then we can derive the remaining ones from these two major definitions. These are also known as the hyperbolic trigonometric functions. So it's not the regular sine, cosine, tangent that we saw. We have this extra factor, h in there, so you can see it right here. We call them hyperbolic functions. So sinh, this is how you pronounce that. You can also call it sine hyperbolic. This is defined as e to the x minus e to the negative x divided by 2. So that's the definition for sine hyperbolic, or you can say sinh. And then the cosine hyperbolic, which is cosh. So it's cosine with the h at the end of x. It's the combination of e to the x plus e to the negative x all over 2. So that's the definition for this. Knowing these two definitions, you can derive the remaining trig hyperbolic functions, such as tangent hyperbolic of x. Now we know the tangent, the regular one, it's sine over cosine. So this will be sine hyperbolic over cosine hyperbolic. Now, since sine is this definition right here, let's replace that so we can define tangent using these exponential functions we have. So it'll be e to the x minus e to the negative x all over 2 divided by cosh. That's going to be e to the x plus e to the negative x over 2. And then I can simplify this algebraically. This will simply give me e to the x minus e to the negative x all over e to the x plus e to the negative x. That will be our definition for tangent hyperbolic. Similarly, you can derive the remaining hyperbolic. There are 3 more: secant hyperbolic, cosecant hyperbolic, and cotangent. Now, let's talk about their derivative, since that is important in calculus. We want to know what is the derivative. So what is the derivative respect to x of, let's say, sine hyperbolic? We're going to derive this by using the definition. Since I know sine hyperbolic has this as its definition, e to the x minus e to the negative x over 2, I want to simply replace that in here. So this is the derivative of this function, e to the x minus e to the negative x all over 2. Now let's differentiate this since we know the derivative of this function. So I'm going to separate the fraction into 2 separate fractions. So we're taking the derivative of e to the x over 2 minus 1/2 e to the negative x. And now using the power rule of integration, we know the derivative of e to the x times 1/2 is simply 1/2 e to the x. And the derivative of 1/2 e to the negative x, that's negative 1/2 e to the negative x times negative 1. And that negative 1 and negative in the front will cancel out. So you get 1/2 e to the x plus 1/2 e to the negative x. Or you can put them together, e to the x plus e to the negative x over 2. So that's the derivative of sinh. Now, if you look at our definition, that looks like the cosine hyperbolic right here, which means that the derivative of sinh is really cosh of x. So we can say that the derivative of sine hyperbolic is cosine hyperbolic. You can also do the same thing for cosh, take its derivative, and you can do the same thing for remaining trigonometric hyperbolic functions. So let's go ahead and find dy dx for this given function. So we're going to be using the chain rule. So we are looking for the derivative of y. So that is dy dx is equal to, this is 1/2 derivative of sinh, but we know that's cosh. We keep the inside 2x plus 1 times the derivative of the inside that's right here. And that would simply be 2. Then we simplify our answer. So dy dx is equal to, the 2 will cancel out, 2.5. That will give us just cosh of 2x plus 1. So that will be our derivative for this function. All right, so here's our last problem. We're going to find dy dz for this particular equation. So on the left side, we have dy dz Z is the independent variable. Derivative of ln of any function is 1 over that function. So this is sinh of z times the derivative of the inside. So the inside is sinh. And we know derivative of sinh is cosh of z. And you can write this as cosh of z over sinh of z. And we know cosh over sinh, that's cotangent. So this would be equal to cotangent hyperbolic of z. So that is your derivative dy dz for this particular problem. All right, so just get used to these functions. They're almost like the regular trigonometric functions, but they are a little different, so just be careful on that. I'll see you guys next time.